Hello, everybody. I'm ZS Caraval from ZK Research, and welcome to another ZKast episode. I'm here today with Craig Theriac, VP of Product Manager from Scale Computing. Before we get into it, though, with Craig, I do want to just give a quick shout out to eWeek. eWeek's ZK Research media sponsor. All ZKasts are done in conjunction with the eWeek eSpeaks program. Now, Craig, you're with a company called Scale Computing, and we're going to be talking edge computing. So before we get into what you do and some of the new products you have, just give us a quick intro of yourself and what Scale Computing does.
Sure thing. So I'm Craig Theriac. I'm the Vice President of Product Management at Scale Computing. I have been with the company in this June. It will have been 12 years, which is hard to believe. Kind of came up with the company when we were a storage company back in the day when we first joined, made a transition into the HCI space probably 10 years ago now with the introduction of Hypercore. And then we have recently transitioned the business again to focus more on edge computing. And so that's kind of who I am and how I came to be in this position at Scale. The company itself, as I said, is primarily we position an HCI product where we're taking servers, storage, virtualization, combining it together into an appliance form factor and servicing markets that have typically minimal or no IT resources. And that can be in the SMB space, where it's 1 to 5 IT administrators who are asked to take on just the infrastructure alongside everything else they have to do, or in an edge computing environment, which is typically a very distributed environment that may or may not have IT resources on site there.
Okay, so let's start edge by talking about the definition of edge. It seems like everybody's an edge computing vendor today, and I hear the IoT edge, cellular edge, there's all these different definitions of edge. So from your perspective, define what edge computing is.
Yeah, so edge computing it's simply anywhere you're running mission critical workloads outside of the four walls of the data center or cloud. That's, in my mind, that is edge computing. In our case, we're selling the infrastructure where you could run that those applications, and it's I think commonly it's referred to as anywhere. Our definitions around that mission critical workload, because I think that's where we provide value is, basically preventing downtime and that sort of thing in those environments. But it's really around, at the edge of the network near the things and people that are generating and interacting with the data. That is what edge is.
That's very consistent with my definition. From a ZK Research perspective, we define edge as really anything that's not a centralized compute source. That being public cloud or private cloud, and everything else is edge, which is interesting because that is about as broad a definition of computing as there is, right? I mean, you're talking anything between your private data center and your public cloud, so there's quite a bit in there. But so where are we in this journey to edge computing? If you were to use the baseball game analogy, the pitcher's warming up, first inning, the relievers coming in.
First or second inning. It's pretty nascent market. Even the term itself is fairly new. It's probably, peak of the hype cycle right now on the term. The reality is that, I guess depending on how you define it, if you include things like Robo's been around for years. The idea that you want to run computing close to the people that are interacting with it, that is not a new concept. I think what's new with edge computing is there's massive data being generated from IoT devices, as you gave us a good example earlier, or workloads that require really, really low latency to make decisions on the factory floor, that sort of thing, where the latency of going to and from the cloud is just too much. Or a lot of cases in customers that I talk to, one of the biggest drivers of needing edge computing is that they just cannot consistently rely on their internet connection. And so due to that, they need some level of autonomy, some resiliency in the infrastructure that they can stay up and operational. I would say regulation is another big driver, depending on what industry you're in or how you interpret the laws in the region that you're in. There could be things like personally identifiable information that you would need to keep locally. And then I would say that last driver there is cost. And none of those things have necessarily changed, although cost is coming down, I would say. And there are new, interesting ways to solve some of these problems around, the amount of data being generated and the amount, the low latency requirements and all that sort of thing. But I would say the need for something running locally been around forever. Edge computing as a concept is in the last few years really taken off and continuing to grow at a pretty astonishing rate.
And I think we're hitting somewhat of a perfect storm here for the growth of edge, because I think as you mentioned, we've always had a need to have some types of edge computing. In fact, there's lots of industries, oil and gas, for instance, where you kind of had to have some kind of edge node because it was difficult to do things locally. But I think if you look at this big desire to change, fan experience or patient experience or customer experience or even employee experience, we need to move the data and the workloads closer to the user. And to me, that's what's driving, edge computing. And I think in addition to that, we've had the rise of, higher performance GPUs and DPUs. We've got flash storage that's available, a lot more or less expensive. And so all those things are kind of coming together. That's allowing the edge computing market to finally take off, right? And so, I think from you're curious, what kind of use cases are you seeing that's really driving edge today?
Yeah, if edge is a broad term, it's like every single industry we talk to has something that is edgy about it. But the ones that I think where scale computing, yeah, I know, right? Sorry about that. Yeah, it's like people always use scale puns around us. It's like, oh, yeah. No pun intended. It's like, yeah, you can't avoid it. Anyway, so it's the use cases that we see at scale computing are around retail is a really big industry for us. Might be running a point of sale system, customer loyalty program. Again, it's really, when I keep going back to that term, mission critical. And what I mean is that if whatever that application is, whether it's container-based application or VM, doesn't matter, whatever that application is, if downtime to that application means that you're unable to process transactions in the case of retail, or it's going to have some, big impact to the ability to get widgets out the factory floor, that sort of thing, that's really the key to it for us. And in the case of retail, that is the point of sale system typically, or the customer loyalty program, where if that goes down for even as few as 5 minutes or so, you'll see people start to abandon carts. That's going to hit the bottom line. Of course, those are running next to things like the grocery retail environment. We've got a couple, talk through some explicit customer use cases later if you want to, but we have a couple customers that are running things like, if you're walking to a grocery and you see the misters going off over the vegetables, those sorts of applications, just small container-based applications, where if they went down, probably not a huge deal, but it's running alongside these other applications where mission critical is the key. Those are, that's usually what we'll see in retail. And I would say the biggest driver there is the autonomy, right? So it's like you might have several locations, right in the main part of town where you've got a great internet connection. You might have some out in, middle of nowhere areas of the world that just don't necessarily have a great internet connection. So they need some level of autonomy to run their infrastructure on-prem. Maritime is another one that I think is, talking about edgy, it's about as edgy as it gets, right? These are seafaring vessels going in and out of international waters, and probably in and out of cell coverage with limited bandwidth and ability to actually get data to and from the ship. And so some level of autonomy is required to run their accounting systems, cargo management, that sort of thing.
Cell coverage is interesting because lack of cell coverage means you need edge, but also 5G allows you to put edge computing in places you couldn't before, because now you can get data to it. So that's kind of interesting. But let's transition to scale computing itself. Please. You mentioned you've been there about a dozen years. When I think of scale, I was introduced to you a few years ago as an HCI vendor. In fact, before that, I think people that are familiar with you might know as a robo HCI vendor. So what have you been up to in the edge computing space? So can you talk about your portfolio there and how you make edge computing deployments easier?
Yeah, I appreciate the refocus a little bit. So yeah, if you've heard of us, you've probably heard of our HCI product. It's called Hypercore. Hypercore operating system is the software that runs on the nodes that allows you to run these clusters on premises. What we've developed in the last few years is I've been working on what we call Fleet Manager that we're happy to announce actually this week. Those two things combine into a really comprehensive solution that we call SD Platform that is explicitly intended to be used in these edge computing environments. And so that's really what we've been up to. I would say one of the interesting things about our HCI play is that those of you that really know us understand that we're bringing the virtualization layer alongside our own storage layer and kind of everything you need to be able to run your applications, and that hypervisor we use is KVM based, and so we have built our own storage layer that's explicitly designed to be consumed by that KVM based hypervisor, which allows us to run on really, really small form factors. And so kind of those two things combine, the introduction of fleet manager alongside just the efficiency of our software stack on Hypercore makes for a really solid edge computing solution.
So Hypercore is the edge computing product itself. Fleet Manager is your management tool. Talk about Fleet Manager and why we need that. And when I think of edge computing, the future of what edge computing could be, right, is putting more data and more workloads in more places. If unmanaged, I could see that leading to chaos, because this distributed computing world we have. I mean, if you think companies have problems managing data today, when it's in 2 clouds and 1 private cloud, wait till they have it in 500 edge locations, right? I mean, this environment can get out of hand really fast. So talk about some of the, what Fleet Manager is and some of the problems that it solves.
Well, let's talk about the problems with edge computing. I would say there are all sorts of problems that once you've decided you can't run in the cloud and you have to run on premises, and that's a big decision to make. You're starting to deal with the fact that you've got limited or no IT expertise on site. Go back to that retail example. You cannot ask the manager of the grocery store to go and deal with IT infrastructure on premises. It's not going to happen. And so, having the ability to remotely manage and monitor becomes essential for those types of workloads and those types of deployments. And that's really where Fleet Manager comes in. But it's combined with a lot of intelligence that's built into Hypercore. And so it's, talk about SC platform, scale computing platform, as an overall solution, combining those two things, because it's really hard to separate them out. A lot of the benefits that you have from Hypercore is the fact that there's a lot of intelligence built into it that does things like monitors thousands of conditions to be able to say, all right, so this is my current state, this is my desired state. How am I going to navigate this path in this clustered environment to get to this desired state, and do so without necessarily being able to connect to the internet? So there's a lot of intelligence that's built into the solution itself that can just sit on-prem and run. But if you're going to manage, as you gave an example of 500 individual sites, you need another layer above that to kind of manage the fleet of Hypercore based clusters out there. And that's where Fleet Manager comes in.
So can I think of it as a kind of a software overlay that lets you manage essentially what instead of a bunch of individual edge computing nodes, you're actually delivering kind of an edge fabric, right? So it looks like one.
That's right.
Is that a good way to think about it?
That's a great way to think about it. It's a cloud-based offering that kind of offers centralized management for all of your deployments. With 1 to 50,000 clusters, doesn't matter. It involves a lot of proactive alerting, kind of gives you a centralized view of everything. Allows you to drill down to that level if you needed to get to an individual level that happened to be experiencing an issue. But it also gives you that fleet-wide view of everything. It's critical.
So in layman's terms, so for people that are sort of technical, you can do for edge sprawl what vCenter did for VM sprawl. Is that a good way to think about it?
I think it's a great way to think about it.
Yeah. So now this is it's a relatively new product, but you do have some customer deployments. Can you talk about a couple of customers and what they did with Fleet Manager and the benefits they saw?
Well, so we have been working on this for a while now, and so we've got a number of customers that are using it. We're officially announcing it this week, making it available to anybody. But with probably one of the best examples that I can give you is with a company called Ahold Delhaize. So this is a multi-billion-dollar grocery retailer based out of Belgium, and they've got thousands of sites worldwide. But originally, when they came to us, they were looking to deploy their first 800 in Belgium to replace the infrastructure they had out at their sites. And so they, at the time, were looking at, we only had Hypercore. And so it was, they needed something to be able to run on premises, to provide that autonomy to run those applications. And that worked great. But ultimately, as they started to roll those out and got into the hundreds, they needed something to act as an overlay. And so we developed a platform with Fleet Manager specifically for that type of use case and gave them early access to that. And so far, the feedback has been phenomenal. I mean, they basically said that it's allowed them to effectively manage these clusters across hundreds of stores to ensure that those applications will remain highly available, and it's saving them a ton of time and money.
Yeah, and I think the best way for the people watching this to understand what the product does is you're going to give us a quick demo right now, aren't you?
Perfect. Yeah, I can talk about all you want, but until you see it, it's not real. Yeah, let me give you a demonstration of the product. First things first, though, just to kind of set the table as to what it is you're going to look at here is as I said, SE platform, scale computing platform, is made up of really two different pieces. One is Fleet Manager, which is the cloud-based offering, as you called it, the overlay to be able to manage these multiple clusters out there. And then we have the software that is running on these clusters. So I guess to just visually let you see what this looks like, I took a picture with my iPhone of my 3-node HE150 cluster. And this is a really small form factor cluster. We've got, it doesn't matter if it's this small form factor, if it's 1U or 2U node with GPU or without, doesn't matter really what the hardware attributes are. Our software running on these things is the same. And in 99% of the cases, when somebody orders one of these, it's going to ship directly from our integrator to the end user at whatever location they want to, so that they can go through the deployment. And I figure just so you can kind of see what it is you're looking at here. Start here, and then I'll go into the Fleet Manager user interface as a starting point. So customers point to fleet.scalecomputing.com. They can use their local credentials, or I often will just use Google, mainly because I cannot type on command. And here I'm logged in, and I actually have this connected to our internal testers organization, which has 19 individual systems, most of which are in some pretty bad shape. This is not actually how it would look, right? The first time a customer is going to log in, it's not going to have any information in there. But once they've deployed, most of the time, this is going to be a very green screen and everything's happy. We've got some fun colors in here to just kind of show off what it might look like. But you've got everything from a timeline of events that have happened, kind of current health status of what's going on in the cluster, even version info across these individual sites. But it is at the cluster level when you first log in. But if you drill down into the clusters themselves, I've got this focused on what I call my HE150 promo cluster, which is that cluster that I just showed you the picture of. And I'm pointing over here because on the other side of this wall is where that cluster sits. That's currently healthy. The very first time somebody logs in and is setting this up, they're actually going to have their nodes show up in here even ahead of that, unprovisioned. And then whenever they go to provision the cluster, everything kind of connects into Fleet Manager so that they can start administering things from here. I'm going to click through into the cluster details and actually pull up the Hypercore user interface. So this is, and we said there are two different interfaces here. This is actually being served off the cluster itself. So this is the Hypercore user interface, and you can see those 3 nodes that you saw pictured there are represented in these boxes at the top. If this were the very first time you're logging in, these would all be blank. There would be nothing on here, but for demonstration purposes, I've got a handful of virtual machines running on here. And usually when I'm talking through kind of the pillars of platform, there are a few things I like to hit on. The first is just the simplicity. I mean, you can get from unboxing to spinning up highly available workloads on the system in less than an hour, typically even less than that if you have any experience with it. And I'll walk through kind of what that looks like manually. Then we'll talk through, an edge deployment. You're not just going to be doing this once. You're going to be doing this likely hundreds of times and need programmatic interfaces to be able to do that, just APIs to be able to automate a lot of that. So let me create a new VM. I'll give it a name, description. You can select the operating system. We do include performance drivers. From here, you're just kind of carving up whatever resources that you need for this particular workload. And then I'm selecting the ISO, which I've uploaded a handful onto here ahead of time. So, I mean, that is it. The very first time you put these in, you're going to plug in the networking, you're going to plug in power, you're going to initialize the cluster by putting an IP address on each of the nodes. And then you can go and create that VM just like I just did. And this is probably a good time to talk about really the benefits of Hypercore, that yes, it is simple, but a lot of the simplicity is it's kind of a mask. There's a lot of complexity going on under the scene. As you can imagine, this is a clustered environment. So we've got all these layers that we're managing, and we have what's called state machines that are doing things like monitoring the state of thousands of individual conditions in every node in the system. One of the things, obviously, it's going to be monitoring is the desired state of your workloads. And so when I just turn this particular Craig workload on, that's a desired state change, which means it now has to decide what to do with that. And in this clustered environment, where does it need to place it? So it's found node 2 in the system is the best place to place that virtual machine. I can actually get directly to the user interface and see the Windows loading files here screen, which probably looks familiar. Once you've done that, I mean, that's it. This thing is going to sit here, if you've architected it correctly, to run in a highly available manner out at the edge of your network. And Fleet Manager comes in to be able to manage across multiple sites in this manner. Let me actually power this off. I think one of the more powerful things about this system is just how those state machines handle failures. I think that's look at edge computing and these distributed environments, and you're looking at, what can happen in that environment when you don't have any IT expertise on site. And one of the big things that can happen is failures, and hardware fails. And that's kind of a fact of life and a fact of hardware. And so you need a system that's able to tolerate those. What you're seeing jump up on screen here is this insufficient memory. It's because one of those state machines that I was monitoring is saying, hey, you started a VM that now does not allow you to fail over your VMs or do things like live migrate VMs around for a rolling upgrade. I went ahead and shut it back off, so those have cleared themselves. But in fact, if it's okay with you, I'm going to walk into the room, grab one of those nodes and bring it back here so you can kind of see what that experience looks like for a failed node scenario. One of the customers that we often talk about, it happens to be another grocery retailer, which I don't need to necessarily fix on that use case specifically, but this was coming into crunch time for one of their busiest times of the year, right before Thanksgiving. And they had a couple of power issues. You imagine, retail environment, you don't necessarily have consistent power, consistent cooling, that sort of thing in these environments. And so there happened to be something in the environment that was causing node failures at a rate higher than what we would expect elsewhere. And so we're on a call with them and they're kind of talking through the issue. And they said, we have to get this, the CIO talking, we have to get this fixed before busy season. And the director of IT was sitting there and said, what? Actually, nobody at the stores has noticed. And what she meant was nobody had noticed, not because there weren't failures. Nobody had noticed because the system's architected in such a way that I can do this. I can pull, this is, an HE150 small form factor. Those of you who recognize the hardware, it's a NUC based platform. It's, if something like that were to fail, like I have pulled node 3 on the system, the first thing that these state machines are going to do is verify this isn't some kind of networking blip. This isn't just kind of transient error that it can't recover from. This actually is a situation where we cannot access this node entirely. So first thing is data redundancy is degraded. The next thing that's going to happen is the system's going to decide, oh, well, that means that this node no longer is able to be accessed for serving those workloads, which means fail that node, restart the VMs without the administrator having to run there and turn anything on. It just handles all that for you. And so the power of that means that you can put these on a ship out at the middle of sea, knowing that, yes, the cargo management system is going to stay online, even if there is a node failure. And, maybe multiple drive failures over some period of time. It's not a big deal. They can come to port, and when the boat is docked and they have IT resources, they can bring on a new node and come and plug that in and kind of restart or heal the system physically whenever it's necessary like that. So here, node is deemed offline. You'll start to see those VMs restart on the other nodes in the system. And that's the high availability piece of this. Now, of course, especially in the edge environment, this is, when you ask what we had done specifically for edge computing, you couldn't, if you had hundreds of sites, you couldn't have this user interface up at every single site, right? And it's not going to work. And so strong possibility you're not staring at the user interface. So obviously we're going to send syslog alerts, we're going to send email alerts, letting people know, but also when combined with Fleet Manager, those alerts are going to populate directly in Fleet Manager to let the administrator know, like, hey, there is something going on at this site. And the last thing I'll touch on is just, how comprehensive this is. It's not just about this one site, right? There are critical alerts going on the site. But if you look at this, we have a fleet of clusters out there. We have a fleet of Hypercore systems that are, maybe in various states of need. A lot of them are healthy. Some of them have some issues. And, the first thing somebody's going to do when they come in the morning is rest assured, first of all, the infrastructure is taking care of itself out at the edge of the network. But if they need to get into any one of these, they can see kind of in priority order what is going on and kind of dig into any one of them and start, figuring out what needs to be done. So that is Fleet Manager, that's Hypercore, and the overall solution, again, SE platform.
Yeah, thanks for the demo. I think that was a good way to to highlight kind of the power of that. And last question, for you, Craig, what can customers expect next? Can you give a little bit of idea into the roadmap of where this goes?
Yeah. So, product management, that my job is to kind of direct the roadmap where we're taking things, which is twofold. Number one, I have power to be able to do that. The other thing is I can't make promises we can't keep. I will tell you that right now we are, so often when these are being deployed in a large environment like this, there's an integrator involved, right? And so when I was talking through here, the manual steps you'd have to go through to set up a cluster, where you're setting up the IP address on every node. And yeah, it takes less than an hour, and you do a few of them, you get pretty good at it. But any steps we can take out on the manual side of things, we're trying to. And so we have introduced, along with this, what we call zero touch provisioning with local USB. So you can kind of take a USB and put it in the back of one of these nodes that has the configuration information that you would need. The next step beyond that is to be able to allow that configuration information to be available directly within Fleet Manager. And so very, very soon, you'll start to see some of that populate into the product, where you can go through and set, here are the IP addresses that I want this specific hardware to have when it comes online. So you can even avoid a lot of the manual steps that might have to happen going through an integrator. Just ship directly to wherever the final destination is. It knows when it comes online, here's the provisioning information it needs, zero touch. It's going to come online, provision itself, and get to a state that you can start creating those highly available workloads.
Good. So it sounds like it's even easier from here. So
that's right.
All right. Well, Craig, so thanks for that update on your definition of edge. I think it's very closely aligned with mine is. It was great to see the new Scale platform, the new Fleet Manager product. And for those of you watching this, I know there's a lot of stuff to do in IT today. The environment's never been more complicated, but edge is coming. There's not a company I talked to that's not thinking of edge in some shape or form. May not be called edge, but it's very edgy, as you said. And so, just as a point of caution, if you don't get a handle on kind of the complexity of it up front, I think you can have an environment that really becomes unruly pretty fast. And so, again, Craig, thanks for the view of what Fleet Manager is. I think that can really help some of the complexity that we've seen in other areas of IT as we've rolled out computing. So, unless you have anything else to add, on behalf of Craig Theriac from Scale Computing, I'm Zeus Caravala. Thanks for watching ZKast, and don't forget to click the subscribe.